Hello students, today we are going to discuss a new topic, that's linear motion. As you can see in the video, the motion of the train is called the linear motion in a straight line. So to start with, let's discuss what are the important quantities which you need to describe a linear motion completely. These are the four quantities which you will need to describe any type of motion: displacement or distance, velocity or speed, acceleration, and time. Now I'm going to discuss each one in detail. For example, distance and displacement. The basic difference between distance and displacement, one is a scalar, other one is a vector. As a result, the displacement has a direction. Depending on the direction, it can have a positive, negative, or zero value. But distance should be always written as a positive value. No negative answer possible for a distance. Let's discuss some examples how they are different. You are throwing a ball upwards, it's going 10 meters and coming back to the same place. So let's calculate the total distance traveled and displacement. Total distance is not difficult. Going up 10 meter, coming down 10 meter, total is 20 meters. But the displacement, what is the final displacement of the body? For example, if you have taken upward displacement as positive, the downward displacement you have to take as negative. So 10 meter positive upward and 10 meter negative downward, the total displacement of the body is 0. This is the difference between distance and displacement. Let's see another example. You are dropping a ball downwards. So it came down 10 meter. If you take plus 10 meter, then moving upward, you have to take minus 4 meter. Means the total distance would be 14, but the total displacement should be 10 minus 4. That's 6 meter. So let's see how can you easily find the displacement. These are the steps to find the displacement. First, you need to find the initial position. Then check what's the final position. Just draw a straight line. This is how you find the displacement of any body. Means you don't have to care about actually how the body has moved. Okay, in displacement we don't think about the actual path. We just consider starting and ending point and draw a straight line. That's what you call the displacement. Let's think about more examples. A body is moving in a circular path and it's coming back to the same point. So we are going to see what is the displacement and what is the distance. Let's say r is the radius of the circle. So the total distance traveled is the circumference, which is 2 pi r. And the total displacement, again, how do you find the displacement? Mark the first point, mark the last point, draw a straight line. Here the first point and the last point are exactly same, means the displacement is 0. So when you complete running in a circle, your final displacement is 0. Okay, now let's take another example. You are moving in a half circle, not a full circle. Then what is the distance traveled and your final displacement at the end of half circle? It is 2 pi r divided by 2, which is pi r, the total displacement. Imagine the first point, imagine the last point, draw a straight line. That is from here to here. That is the diameter, or 2 times the radius. So this is the displacement of the body. Means what you need to understand is distance and displacement are entirely different. Now let's see what will happen in 2 dimensions. For example, if you are going from A to B, then B to C, what is your distance traveled and what is your displacement? So let's take A to B distance is 3 meter and B to C is 4 meters. So what's the total distance? It's very simple, it's 7. We don't have to consider which way you moved, but what's the total displacement? Like I told, think about the first point, think about the last point, draw a straight line and put a direction from where to where. So you have displaced from A to C, and that is the final displacement. And how do you find this? Remember what we did in vectors, and this is a right triangle and that's a hypotenuse. So directly you have to use Pythagoras. Root of a square plus b square, that's 5 meters. So this is your final displacement. So let's move on to the next set of quantities, that is speed and velocity. Speed is a scalar but velocity is a vector quantity. As a result, velocity can be positive or negative, but speed answer should be always a positive answer. No negative answer possible for speed. And the definitions goes like this. Velocity is displacement over time because it's a vector, and speed is distance over time and it's a scalar. Let's see how they are different. A body is going in a circular path at a constant speed. Will the velocity be constant? Already it's given speed is constant. But is the velocity remaining constant? Let's check. Let's mark the directions of velocity at every point. This is how the velocity should be marked at any point. If the motion happens along a curve, you have to draw the velocity as a tangent. The velocity should be drawn as tangent at each point. This is the velocity at that particular moment. So if you see at each moment, what happens to the velocity? Is it changing? Yes, it is changing because the direction is changing. Remember, the magnitude is same, but even if the direction is changing, we have to say velocity is changing because it's a vector and magnitude and directions are equally important. Okay, so here the speed is remaining constant, but the velocity is changing. So this is possible because speed and velocity are entirely different things. But sometimes you may not be able to find the exact speed of a body because it may not be going with constant speed, or there may not be any uniform pattern. It may be moving something like this. In such cases, we won't be able to find the exact velocity at a point. Instead, we go for an average velocity. So average velocity doesn't care how you moved. You take the total displacement and divide by the total time. So that's called average velocity. This is done in cases where finding exact velocity is not possible. One example, if you have completed one circle, what will be your average velocity? So the equation is there. Average velocity is total displacement over total time. But here, the total displacement is already 0 because you are coming back to the same point. Means your average velocity will be 0. So however fast you run in a circle, finally your average velocity will be always 0. Let's do one question comparing the average velocity and average speed. So we are going to calculate the average speed and average velocity. So let's find the average speed first, which is distance over time. So the total distance traveled, already we have seen it's half of the circumference, and the total time is 50. So the average speed is 15.7 meter per second. But what will be the average velocity, which is total displacement over total time? The average velocity will be 10. Means the average speed and average velocity can be different. Relative velocity means what is your velocity compared to another person. Okay, in fact, in everyday life what you get is only relative velocity. We will never get the absolute velocity of something because we measure velocity comparing with something else. Two cars A and B are moving in the same direction. The car A was moving faster. The car A was moving at a speed of 10 meter per second and car B was moving 4 meter per second. The question is, what is the relative velocity of A with respect to B? Means, if you are a person sitting inside the car B and you are looking at the car A, how fast you feel the car A is going. So what's the velocity of car A if you compare with car B? That's the question. Okay, so let's see how to do this. Always you have to take first the body which you are measuring, that is 10. Here we are measuring the speed or velocity of the car with respect to B, okay, A with respect to B. So that's why I have taken A velocity first, that is 10, minus your velocity. So you will feel like the car A is going at 6 meter per second because already you are going at 4 meter per second. So always take the one which you are measuring as the first velocity minus your velocity. That will be the relative velocity. So let's take another example. What is the relative velocity of B with respect to A? Now you are sitting in car A and you are measuring the speed of B. So remember the equation. First you have to take the body which you are measuring. So here I am measuring the speed of car B. So I am taking that first. 4 is the velocity of car B and I am sitting inside car A. So it's 4 minus your velocity, that's 10, minus 6. What does that mean? That means if you are sitting inside car A, you will feel like the car B is going backwards. That's why minus 6. So that's relative. Actually it's going forward, but with respect to you, you will feel like the car B is going backwards, as you can see. So you might have experienced this in your everyday life. This is an example of relative velocity. Now let's see another example. Another two cars, A and C. You can see how they are moving. They are moving with the same velocity but in opposite directions. So the question is, what speed you will feel the car C is going if you are a person sitting inside car A? I am using the equation. I have taken minus 10 for car C because you are sitting in car A. So normally your velocity you can take positive. That's what we do normally. So the car C you have to take as negative if you have taken car A as positive. Means the relative velocity will be minus 10, again minus 10. It's minus 20. You will feel like the car C is going double the speed in the opposite direction. That's the meaning of minus 20. Now another example. Two cars going at the same velocity in the same direction. Both have the same velocity and they are moving in the same direction. If you are sitting inside A, how fast you will feel the other car is moving? The velocity of car D minus the velocity of car A, you get 0. Means if you are looking from car A to car D, you will feel like the car D is not moving because both of you are moving at the same velocity in the same direction. So this is the concept of relative velocity. Now what if the objects are moving in 2 dimensions? All the previous examples we have taken in 1 dimension. Let's see this example. An aeroplane is heading towards the north side with 100 meter per second speed, but there is a wind blowing towards the east with 30 meter per second. Calculate the velocity over the ground. Means if you are looking from the ground, what velocity you will see the aeroplane going. Exactly the same rule for vectors. So you have to add all the velocities and that is the resultant velocity, or it's same as the relative velocity. Means you will see the aeroplane moving in that direction. That is the relative velocity of aeroplane with respect to you. It's exactly same as finding the resultant velocity. And you can calculate the value using Pythagoras and you can find the direction using Stoccato. The next quantity we are going to discuss is acceleration. Whenever there is a change in velocity, we call this an acceleration. Here the velocity is increasing and we call it as acceleration. And if the velocity is decreasing like this, we call it as a negative acceleration or a deceleration. Acceleration is defined as how fast the velocity is changing. Acceleration is defined as rate of change of velocity or velocity change over time. Any change in velocity can create an acceleration. Even the car moving in a circular path at constant speed, let's say it's moving at constant speed, but is it accelerating? Yes, it is accelerating because there is a change in velocity, because there is a change in direction. Let's classify the type of linear motion. Basically, there are two types of motion. One is called uniform, other one is accelerated. Uniform motion, the property is velocity is constant. The body is moving without any acceleration, something like this, a car moving at constant velocity. Means it is covering equal distance in equal interval of time. This is the speciality of uniform motion. But when you come to accelerated motion, the speed of the car may be either increasing, or sometimes speed of the car may be decreasing, or it may be even changing the direction. We are going to study the equations for each type of motion separately, but remember, each motion has its own properties and its own equations. So first of all, let's see uniform motion. Uniform motion is really simple because velocity is constant. Directly you can use the equation velocity equal to displacement over time, or speed is equal to distance over time, because it covers equal distance in equal interval of time. For example, this is a very simple question. We want to find the speed and it's given it's moving at constant speed. So directly you can substitute distance and time, you get the velocity. But accelerated motion is different. You cannot use directly distance over time. If you use this equation speed equal to distance over time for an accelerated motion, then if you substitute the total displacement and total time, what you get will be an average velocity, not the velocity at a particular instant. How do we actually find the final velocity or velocity at a particular time? Or even if they ask acceleration, how do we find the acceleration of the body? Because those things are not there in the equation. So this is not the equation we are going to use for accelerated motion. For accelerated motion, we have special set of equations which are called the Shewhart equations, or the equations of motion, or Newton's equations of motion. And these are the equations. All these equations are directly given in the formula sheet, so you just have to identify which to use in which situation. These are the four equations of motion. The last equation, the one you see in blue color, there is a difference between that equation and the other three. The difference is the term acceleration is missing. Does that mean that equation is for non-accelerated, that is uniform motion? No, it's not. This equation is also for accelerated motion, and this equation will be very useful if you don't know the acceleration. It's an accelerated motion, but you don't know the value of acceleration. In such cases, this equation is really useful. So that's the difference between this and the other three equations. Now we are going to see the rules. When you apply these equations, there are a lot of limitations. Let's see what are the rules. First thing is, these equations are applicable only if acceleration is same. Means you cannot apply this equation if the acceleration of the body changes during the motion. Then you have to split into different motions except time. Every other quantity in these equations are vectors. Displacement, it's not distance, it's displacement. Initial velocity, final velocity, acceleration. Every quantity except time in those equations are vectors. And what's the limitation of a vector? You cannot add or subtract them directly if they are not in the same line. So all these quantities, the displacement, initial velocity, acceleration, everything should be in the same line if you want to directly use those equations. For example, if you take upward as positive, the downward quantities you have to take negative. There's no rule upward should be positive. You can take any way you want, but opposite direction should be taken with opposite signs. Now let's see more detailed description of what you meant by opposite signs. Let's consider first quantity, that is displacement. How some quantity, some displacement, first quantity displacement, how some displacement are taken. Let's see why displacement can be positive or negative, or which displacement you have to take positive and which one to take negative. Let's see an example. A body is going from A to B. It's coming back to another point C to the left side of A. So from A to B, it's going like 10 meter and it's coming back and moving to another point C, which is 3 meter away. What is the final displacement of the body? So if you see, A to B is 10 meter. If you have taken this as plus 10, then when it's coming back, you have to take minus 10. Means when it comes back to the point A, the displacement became 0. Again, it is continuing that direction. That direction means the direction which you took minus 10. In this example, I am taking right side as positive because initially I took plus 10 meter. Then I have to take left side as negative, that is minus 10. Then again it's going to the left side, means the final displacement of the body is minus 3 meter. How do you choose the direction of velocity? Pretty simple. Moving to the right side, if it's positive, left side is negative. You can take any way you want. For example, if something is moving upward, if it is plus, then moving downward should be taken as negative. In circular motion, the direction of velocity continuously changes. So if that point is 10, exactly the opposite point should be taken as minus 10. So direction of velocity should be always same as direction of motion. That means velocity is the quantity which decides the motion. If velocity is upward, it means it's moving upward. Acceleration will not decide the direction of motion. It's velocity that decides. But if the path is a curve, like we have seen in circular motion or in a projectile motion, you need to draw a tangent at any particular point to get the velocity at that point. You are throwing a ball upward and it's coming down. What happens to the acceleration? When it is going up, what is the direction of acceleration? And when it is coming down, what is the direction of acceleration? What you need to remember always is the direction of acceleration is decided by the force. In fact, the resultant force. So, if the force acting on the body is upward, the acceleration should be upward. If the force is downward, the acceleration should be downward. It doesn't matter which way it is moving. So moving upward doesn't mean acceleration is upward. Moving upward means velocity is upward. You know, the only force acting on this body is weight. Remember, we are ignoring air resistance throughout. The only force acting on this body is its weight, and you know weight is because earth is pulling downwards. Means throughout the motion, whether it's going upward or coming down, throughout the motion earth is pulling it downwards. Means the acceleration is always downwards. Even if the ball is going upward, the acceleration is downward because acceleration depends only on the force. If you compare with the velocity, see, the velocity is upward and becomes 0 there and again increases. But throughout this time, see what happens to acceleration? Acceleration remains constant because the weight or the force is always constant. But see the change in velocity. The velocity, as it goes up, it goes on decreasing, becomes 0. Then again it will is on the other side. A car is coming to a stop. Brakes are applied and it came to a stop. What is the direction of acceleration of the car? So what you need to think is, what is the direction of resultant force? You can see the resultant force is against the motion. The brakes, the applied force is pulling the car backwards. That's why it's getting stopped. otherwise it will still continue to move. So the resultant force is acting backward. Acceleration should be in the same direction as resultant force, so it should be also backward, but velocity always depend on the direction of motion. Like if you drop a ball downwards, the acceleration is downward and motion also downward, so the body will accelerate, the speed will increase. But when you throw a ball upwards, the motion is upward but the acceleration is downward. As a result, the body is decelerating or the speed is decreasing. So what you need to do is first write what is given, the so what values: displacement, initial velocity, final velocity, acceleration and time. So displacement, I don't know. You are asked to find the displacement. Initial velocity is given, acceleration is given, final velocity, nothing is given about final velocity, acceleration is 2 and time is 5 seconds. It's always better if you write the values like this. Now let's choose an equation. This is the second step. You have 4 equations and based on what is given and what you want to find, you need to choose the equation. For example, you want to find the displacement. Means you have to choose an equation which contains displacement. The other quantity should be u, a and t. The only equation which matches all these criteria is ut plus half at square. In this question, you are asked to find the initial speed of the car, like a car is coming to rest. So let's write the SUVAT values. S, U, V, A, T. It's given centimeter. Remember, you need to convert to meters. Initial velocity you are finding. Final velocity is 0. How did I get final velocity is 0? Because it's given it's coming to rest. Acceleration, nothing is given about acceleration. So I am going to choose an equation which doesn't contain acceleration because I don't know the value of acceleration. There is only one equation which does not have the term acceleration. That is this equation. Then you can directly substitute the values. Remember, I have converted centimeter to meter. In this question, you are asked to find the final velocity. Write SUVAT. Here, the difference is acceleration I have taken negative because it's given it's decelerating. So deceleration is always negative acceleration. Final velocity we are finding, the time is given, initial velocity is given. So let's choose the best equation which has all these quantities. That is v equal to u plus at. So all these examples we were discussing objects moving horizontally. Now let's think what will happen if you throw something upwards or if you drop a body downwards. All such motions, if a body is moving completely under the influence of gravitational force, it's called the free fall. Free fall doesn't mean always falling downwards, it can be even moving upwards. The only meaning is the body is completely moving only under the influence of its weight. As a result, the only acceleration of the body is 9.81, which is called the acceleration due to gravity. And the direction of acceleration is always downwards because the weight is always acting downwards. These are the speciality of, and objects can be moving upward or downward. In both cases we call free fall if only weight is acting on the body. When you consider free fall, you have to ignore the air resistance because the only force possible is weight. In free fall questions, sometimes there will be two directions involved. It may be going upward then coming downward. So it's always better to choose one direction as positive, one direction as negative. For example, here I am taking downward as positive direction. You can take any way you want. So let's write Suvat. Time, they haven't given anything about the time. Displacement, you are going to find, that's why I put a question mark. Dropped, from the word dropped, you have to understand the initial velocity is 0. If you drop any object, its initial velocity should be 0. Final is already given. Acceleration I have taken plus 9.81 because I know acceleration is downward because the earth is pulling downward, and the downward direction I am taking positive. That's why acceleration is positive. Now let's choose the equation that will best work with this question. I am choosing v square equal to u square plus 2as because I don't know the time. The ball, after hitting the ground, it's bouncing back. You can see the velocity has reduced. This will be due to the sound and heat produced due to the impact of the collision. I am taking this time upward as positive. I am going to find the displacement. Initial velocity is given 20. The final velocity, it says maximum height, means it's not going again, it's not traveling again, means the velocity is becoming 0. That's why it's not moving further. Now acceleration, I have taken upward as positive, but you know the acceleration is always downward because always the earth is pulling downward. So downward should be negative. That's why the acceleration I have taken negative. If you have taken upward as negative, velocity will become negative and acceleration will become positive. So you can take any direction as positive or negative, but you have to follow the rule for all the quantities like displacement, initial velocity, final velocity, and acceleration. I'm choosing the same equation because no idea about the time. A ball is thrown from some height like 1.2 meter. It's coming back and hitting the ground. So it's not stopping to the place where it was thrown. It's going up, reaches the maximum height, comes back and hits the ground. So you are asked to find the initial speed. Okay, let's choose one direction as positive and one direction as negative. In this question, I am taking the upward direction as positive and downward direction as negative. At the end of the journey, what will be the displacement? Okay, we are going to write all SUVAT values. So the displacement of the body should be minus 1.2 because it was going up some distance, a positive displacement, because upward I am taking positive. So let's say it's like 10 meter it went up. Then when it comes back I have to take minus 10. When it reaches here, it will complete minus 10. Again it's continuing to move that minus direction. Okay, finally it's moving in the negative direction. Downward I have taken negative, means the final displacement is minus 1.2, not plus 1.2. Initial velocity, we don't know. That's what we are going to find. Final velocity, we have no idea. Acceleration, will it be positive or negative? I am taking upward as positive. And you know, acceleration throughout the motion, from the beginning to the end. The earth is pulling downwards, so the force and the acceleration is downwards. And downward here is negative. Total time is given. I'm going to find an equation which matches with all these things, that is sometimes the questions will have more marks. This question was a 4-mark question. So if you see there are more than 2 marks for a question in linear motion, then you can understand that you need to use more than one equation. I'm writing all the quantities for the second statement. Okay, I'm not looking at the first statement. I'm just looking at the question. Let's write SUVAT for the second part. I want to find a distance. Initial velocity not given. Final velocity not given. Final velocity I mean after 3.8 seconds. Whether the ball is going upward or coming downward, all the time acceleration should be downward. Total time is 3.8. And this is the equation connecting most of the things given there. U is not given. If you could somehow get the value of initial velocity, then it's solved. The purpose of the first statement is just to find the initial velocity with which the ball was thrown. I'm writing this all for the first statement. The displacement is given in 28 meters. Initial velocity we are going to find. Final velocity is 0 because it rises to a maximum distance. Acceleration minus 9.81. Time is 2.4 seconds. In the first statement, I know everything except initial velocity. So you could use any equation to find the initial velocity. I'm using that equation I got the initial velocity. So the initial velocity I'm getting from the first state. Now I'm going to substitute it here. In place of u, I can substitute that because I already found the initial velocity for the second motion. A rocket is fired, but after reaching some point, its engines are turned off. Until 1000 meter, it has an acceleration of 4. But after 1000 meter, when the engine fails, still the rocket will continue to move upward because it has velocity. Even though Earth is pulling down, the rocket will still continue to move upward, but the acceleration will be 9.81 downwards. There are two accelerations during this journey. Initially, it was accelerating at a rate of 4, and finally, the acceleration changed to minus 9.81. No equations of motion you can use with two different accelerations. Every equation of motion you can substitute only one acceleration. Means you need to consider each part separately. What I know is the red colored part, the total distance is given 1000, and the green colored part, that's what I'm going to find. But I know the acceleration, it's minus 9.81, and I know the final velocity is 0 because it says the maximum height. But I don't know the initial velocity, or I don't know the time. I'm planning to use this equation v square equal to u square plus 2as to find the height s. But the problem is I don't know the initial velocity. U is not given. So if I could get the initial velocity that is here, okay, not at the beginning. I'm trying to find this initial velocity using the red colored path because the final velocity when the engine failed should be the initial velocity for this motion. Means whatever final velocity you got at the end of this red colored path should be the starting velocity for the green colored path. Let's see what things I know. Initial I know it's starting with a speed of 80. Final velocity I don't know, but acceleration I know it's plus 4. This time I want to find this final velocity for the red colored path. The final velocity is 120, which will be the initial velocity of the other motion. So I can directly substitute 120 here because these two velocities are going to be same because it's the same motion, it's a continuation of first motion. I'm substituting 120 there, but remember minus 9.81. Now the acceleration is different. The Earth is pulling now downwards. So I got 734 meter. Remember that's only after the engine failed. The question says to find the maximum height, means it should include from the beginning. So I'm adding the initial 1000 plus after engine failed, it traveled 734. The problem is the values are not given. So you cannot substitute the values and do the calculation. From rest means initial velocity is 0. Acceleration, it's constant, it's uniform. Then time, we know it's double. We have an equation but we don't have the values, all the values we don't have. Like acceleration value we don't have. Time, we don't have a value, we know just it became 2 times. Substituting some random values and doing the calculation will take a lot of time. Means you cannot use the entire equation in these type of questions. You have to use the relation. The relation between two quantities which are varying, which are changing. For example, here you are asked to find the relation between displacement and time. What will happen to the displacement if the time is doubled? So I am going to change this equation into a relation. The equation will have an equal sign and the relation will have this sign which is proportionality, directly proportional. So whenever you put this proportional sign instead of this equal sign, you will have to remove all the constants and all zeros. Initial velocity is 0. The whole term will go 0. Now they have given acceleration is a constant. When you remove the equal sign and put the proportionality, you have to remove the constants also. I am removing a. So now I have only the two quantities which are asked in the question. Means the relation between displacement and time is s is directly proportional to t square. This is how you make a relation out of an equation. You remove all the quantities which are 0 and you remove all the constants. Constants for this particular question may not be a constant for another question. The meaning of this statement, s is proportional to t square, is whatever happens to t square, same thing should happen to s. For example, if the right hand side increases by 10 times, the left hand side also should increase by 10 times. The right hand side means t square. Remember, it's not time, it's time square. So what's given in the question is time increases by 2 times. T becomes 2t. What will happen to s? But if you want to know what will happen to s, you should know what happens to t square. Not t, t square, because that's the one which is proportional to s. So I'm going to find if t is doubled, what's going to happen for t square? Easily you can find just by putting a square to every term. If you put square on both sides, the equation is not going to change because you are doing the same operation on both sides. Now I'm going to remove the bracket, so you can get t square will become 4 times t square. 2 to the power 2 is 4. T to the power 2 is t square. T square value now increased by 4 times. So t square increases by 4 times. That's what you understood from this statement. So if t square, that's the right hand side, if t square increased by 4 times, the left hand side should also increase by 4 times. Means the distance will be now 4 times greater than the first distance. The new distance will be 4 times s. Here you are finding the relation between displacement and speed. So it has a speed v after a distance s. What will be the speed after a distance 2s? Remember, it's not moving at constant speed, it's accelerating. So answer is not 2v. S is double is given. U is 0 because it's given from rest. Acceleration, we don't know the value, but we know it's constant. We asked to find what will happen to this. Time, nothing is given about time. So I'm going to find an equation which doesn't contain time. But as I told, the full equation will not work. You need to make a relation between v and s. But it's easy because u is 0, this part is 0, acceleration is constant, so 2a will also get removed. This is the relation between displacement and velocity. What will happen if you double the right hand side? The right hand side is increased by 2 times. It's given in the question, displacement is increased by 2 times. Right hand side is increased by 2 times. The left hand side should increase by 2 times. Left hand side means not v, it is v square. So what you will know is v square increases by 2 times. V square will become 2 times v square. But the question is not about v square. The question is about v. If you want to know what will happen to speed v, you need to remove this square. What do we do to remove the square? We put square root. Just put square root to every term. The left hand side, the square root and the square will cancel. You get v. You will know what happens to v now. The right hand side, square root 2, then again square root v square. So square root 2 will remain, it won't get cancelled, but square root of v square, you get v. Means velocity will increase by root 2 times. The new velocity will be root 2 into old velocity. S increased 2 times, so the left hand side v square should increase by 2 times. So v should increase by root 2 times. So that's the end of this topic. Thank you.